Hello. Good evening, everyone. Okay, I lost. It's very chilly, and I have my sweater on. Quick introduction of who I am and what do I do. My name is Chyuan, or you can call me Chee if it's a bit too complicated. I work for Nethermind, Voyager team in Nethermind, and I'm a developer. So today I'm going to talk to you about Voyager, and the title of my talk will be Starknet Data at Your Fingertips. So for those who are not familiar with what Voyager is, this is probably a good introduction. For those who are familiar, also I hope that my talk will be able to give you more insight as to how to use Voyager. So okay, without further ado, let's start. These are the basic building blocks of a blockchain. So we have blocks, we have transactions, we have contracts, we have events, and in the case of Starknet, we have messages. So all these things come together to form and have information of what a blockchain should look like. And it's very important for us to get to know them, get to understand what's inside, because these building parts contains the data and the structure that we're interested in. I would like to draw attention to what we would normally use blockchain for. So back from the era of Bitcoin, the use case of blockchain is just to transfer Bitcoin. So Bitcoin as a store of value, you're transferring the Bitcoin to your friends. So at that point of time, what is important was to know that if your transactions succeed. So over here, I attached a nice screenshot of how it looks like in Voyager. So there are a couple of status. I will go through that later. And also how much is being transferred, right? Like how much money I transfer to you, that is super important. And the most important thing, who transfer money to me and who am I transferring for? So these are the things that we are normally interested in back in the days of Bitcoin and the early stage of Ethereum, before the advent of smart contracts, so on like that. We can do a lot more magic, which I'll show you again later. So let's imagine like the world without Block Explorer. Right now, we are spoiled with choices, like Etherscan is there. And the first thing you guys probably do in transacting in an EVM chain is to go to like whatever scan, and you realize that the UI, the UX is very similar to the Etherscan we know and love of, because we are spoiled by the existence of Block Explorer. So let's imagine in the case that without Block Explorer, let's imagine how would you decode, how you understand the data that you are interested in. So let's look at a transaction. This is how a transaction in Starknet will look like. Let's say if I were to interact with a contract, bad decision to use dark mode. Everything is so black. I will make it brighter next time. Bear with me. So you can see that this returns is a very JSON kind of format. So for those who are not familiar, JSON is a structured response that devs like to use. What you need to do is that you need to extract data from the response. So for example, if I want to know the fee is 0x ABE F777 blah blah blah. And this is in hex. So hex is not something that we work on a day-to-day basis. So you need to copy that, and you need to type in Google hex to DEC converter, and the first result, and you just paste that in, and you see, oh, okay, this is the value that I'm used to. So that is alone is a work, right? It's a bit tedious, but it's still doable. And again, and if you want to know, like, oh, okay, what contract am I interacting with? Okay, you get the contract. And then you make another call. In this case, in Starknet, get class add, and you are able to return. And you are able to see like the ABI of the contract. So again, you can see that this is probably not the best experience. If let's say Block Explorer would never exist, I personally, in my own opinion, I don't think blockchain will take off. Because this is so hard to use. Like, you need to call the data, you need to know how to decode the data, you need to perform multiple actions, you need to call different endpoints. So these are the two of the 30, 40 endpoints that are available, so you need to be creative, play around with this. So it's what the TLDR. It's tricky, it's hard, it's time consuming, it's not efficient. And I haven't got to the point of ERC20 token transfer yet. And what about analyzing DeFi protocols? You need to make even more calls. You need events. You need to decode events. You need to understand what an event means. So some event comes in certain order, and you need to know, like, oh, okay, what does it mean if this one comes before that? Doing those manually by calling the RPC endpoint and reading off from the response like this, it's going to be so painful. Trust me, you do not want to do that. You could try. I don't encourage that. So yeah, there you go. World without Block Explorer, pretty painful. Probably not what you want to do. And Block Explorers are very essential and a very key component of blockchain. Basically, every successful chain will want to have a Block Explorer. So I want to give a brief introduction as to why Nethermind is building a Starknet Explorer. One of the reasons is that Nethermind is an early supporter of Starknet, and we build tools aside from the Explorer as well. One of our other very successful tool product is Juno Client. So it allows you to run a node on the Starknet ecosystem, and it's written in Golang. That's another product we built. We also have various products, and if you want to know more, feel free to talk to me about that. And Explorer, like I said, is a very major component in a striving and thriving blockchain. We definitely need that. So someone has to build that. And in this case, the Nethermind team decided to do that. So yeah. And one thing that's super important is that Starknet is different from your classic EVM. So Starknet is not EVM compatible. And thus, the Block Explorer will be different from our Etherscan that we know and love of. So basically, Etherscan do not support Starknet out of the box. So in other words, we cannot have Etherscan. So someone has to do the work. So Voyager is here, right? So now, let me take you to the present, the world with blockchain, Block Explorer. This is how it looks like. Nice, very futuristic. And included a bit of cute meme. Let's explore with Voyager. Let's explore blockchain with Explorer. Let's explore Starknet with Voyager. So I'm going to give a slightly more complicated example than the last one I gave. So let's try to analyze a swap. So for those who want to follow along, I should have included a QR code. This is the link of how a swap look like. So the first thing that you come to this page is that you look at the transaction detail. So basically, after a swap, you'll be given a transaction hash. The first thing you do is to click on it, or you copy paste. Search in Voyager. The first page that you will be how can I say you'll arrive at, it's the transaction detail page. So the very first thing that I personally notice are that, hey, these tools are no longer the hex data that is human readable, not very human readable, and not very easy to understand. So one thing that Block Explorer does is that we do name taggings. We give certain addresses that are well known a name, so that every time you come to an Explorer, you know that, hey, look, the two address that I'm interacting with is in this case SIFSwap. So I roughly can know the gist of this transaction. Someone is trying to perform a interaction with SIFSwap, and there's a transfer of USDC. Because in the world of the blockchain, there are many tokens. In this case, the USDC and ETH is being involved in this swap. So that instead of having to read the 0x address, you will only need to read human readable names, like SysSwap in this case. So very cool. And of course, there are other details, but I won't go through them one by one. Yeah. Oh, yeah. The next thing you can do is that you get to know who is the sender. So the sender address in this case, because there are so many senders out there, so most of the time it will be greeted with only the hash. But if you are someone who's well known, like Vitalik, and Vitalik address is made known, the Voyager team will give this address a name, and then you will also have the same experience at the name tagging. And of course, you get to see like how long ago this transaction was made. Which could be important because you kind of want to know, like, for tax purposes, like, when did I perform this transaction, and how do I report tax, and so on and so forth. So timestamp could be important for you, depending on your use case. And the next thing to do is you're able to analyze. Okay, so if you scroll down from in the same page, you can see the function calls that are involved in that transaction. So in this case, it's actually multi-call. So the first thing you see is that you get to know the name of the function that you are interacting with. So to first perform a swap, you need to approve the token. So you get to see this transaction is calling the approve function of the Starkgate ETH token, so that I'm approving the spender to spend our ETH token, to spend this much of ETH token. If you were to click on the decimal tab, you get to know that, okay, this is the amount that I'm approving this spender to spend our token on our behalf. And the second transaction, the second function that is made in the same transaction is called swap exact token for token supporting fee on transfer tokens. So this function name is pretty explicit. So you kind of know that after approve, you're performing a swap, and you know that it is supporting fee on transferring token. And these are the input details that comes along with it. So the things that normally people would be interested in are the amounts. So in this case, it's hex, but you can convert them to decimal, and you're able to see that in this form. So this amount is being used to buy this amount of ETH. So why do I know this is ETH and this is USDC? Because I remember from my previous slide that like this part, and this part. So use that to infer that these are the two in and outs. And for those who are more interested in how the route of a swap looks like, this is the routes that you take, because in the world of AMMs, there are liquidity pools, and sometimes you need to make multiple hops. Sometimes for a better price, sometimes sometimes because some pairs are not available. So these routes are will be needed to be specified to use this function. And it's very clear. You can see that the from address and to address of each hop. Yeah. And finally, we have the swap token. Oh, all right. This is, yeah. Oh, no, hang on. Okay. This is something that I talked about before. Okay. And this is a clearer view of how a route look like. Yeah. Okay. So that's how a transaction will look like. And one thing that in a transaction, one thing that you may want to understand is the events. Because events normally, 5 more minutes? Oh, adjust the light. Oh, okay. How much time do I have left? Oh, it's much better, but how much time do I have left? 6 minutes? Cool, thank you. So we have events. Events, this is the same transaction. Events will let you know like what happens in the state of this transaction. So we can see that in this transaction, the transfer, execute, swap, sync, fee, blah, 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 being recorded. So events could be useful for you if you are running your own indexer. You want to use events to improve the UX for users. And it's just also a good way for maybe people who understand more about the protocol to quickly understand how exactly this transaction is being done, the internals of a transaction. So events are a good way to do it. Oh, it kind of messed up the thing. So yeah. So let's look at the swap contract. So I was talking about the transaction. So let's click into the contract and look at how it looks like. So right away in the contract page, we are given, we can see the class hash and the type. So type is something that we identify because type is already based on the ABI, right? And to really identify the ABI, you have to like look into the ABI code and know that, okay, these are the functions that we have, and is it ERC20, ERC71, so on and so forth. And in Voyager, we have already done that for you. So without having to look into ABI and analyze it for itself, we know that it's ERC20, and this contract is ERC20. That's a very convenient way to let you know the type. There are other types as well, like ERC721, 1155. Is it a proxy contract or not? Is it an account contract or not? And of course, in the world of Starknet, there are concepts of classes. So we also have the class hash being displayed over here. A class hash basically represents the logic of a contract. And if you scroll down for a bit, there are multiple tabs, but today we are going to focus on only a few. The code, which you'll see the contract ABI. If it's verified, you get to see the source code. If it's not, it's like that. And of course, the class hash. And of course, for people who also want to interact with the contract, you can directly read the contract from the read and the write contract tab, meaning that to interact with the code, you interact with the contract, you do not need to write any code. It's a very quick way to test your contract, especially in testnet, or you want to be fast. So I've known people who uses this to front run people in a protocol that doesn't have a front end yet. So probably that could be you. Messaging is something that is unique to layer 2s, because basically there's an interaction between layer 2 and layer 1 via the bridge for a couple of reasons, such as bridging tokens, and they kind of extend that functionality to also bridge data or messages, depending on the use case. So in this case, I only show like a list, and in this case, they all happen. We show the direction, like L2 to, either they are from L2 to L1 or L1 to L2. We show from the from contract and the to contract. So when it's L2 to L1, the from contract, it's a layer, it's a Starkgate, it's Starknet, one of the tokens. We should probably highlight that better. And the to contract is the layer 1 contract address that's on, in this case, mainnet. And this page will be revamped to have improved user experience. So I'm not going to talk too much about this one. And if you click into the message, you're able to see like the content or the payload of what the message is trying to do. In this case, it is a bridge transaction. Why I know is because I scroll a bit down. I scroll down a bit more, and we actually identify for you if this message is a bridge token or not. It's a bridging action or not. So in this case, it's trying to bridge. It's trying to withdraw. Trying to withdraw how much? 0.000003 ETH to mainnet. It's trying to get out from Starknet with this small amount. And one thing I really want to highlight is that we have analytic tools. It's a good way to understand how the network performs. So one of the more famous graphs are like the transaction queue, because it kind of shows like how busy the network is, or how long do you have to wait for your transaction to get included. So this could be a good metric should you want to be quick. Of course, there are multiple charts over here as well. Not going to go through all of them for time reasons. And so Voyager, you kind of have to scroll, you observe, you explore with the UI and the data that we have prepared or indexed for you. But hey, wait, sometimes you are too lazy to scroll. So why do it manually when you can do it via API? So one thing that I really want to highlight into this session is that we have API support, and it's on beta release, and this is how the docs looks like. And for those who are interested, I have included this QR code for early access. So I'm going to leave it up here for like for some amount of time. But again, let me know if you would like to get early access. I'm more than happy to let you try it out. I'm going to just drop it here for like slightly longer. Actually, I see some phone scan. Okay, very cool. I see that everyone has scanned. And finally, I'd like to thank everyone, and happy to take questions. Do you have a question here? Okay, here's a question. Do I walk over, give him the mic? Oh, he has another mic. Fantastic.
Sorry.
Okay. Let's give you a couple of minutes.
Hello. I think as we all...
Is it working? It's not working?
Yes. Okay. As we all know that in Starknet there are two major explorers. One is Voyager and the other one is Starscan. And although I'm a big fan of Voyager, but without being biased, why do you think that a user would choose Voyager over the other alternatives?
Okay, this is a very interesting question. First of all, I really think that it's important for an ecosystem to have not only one explorer, but multiple competing explorers. In the world of Ethereum, we are very used to Etherscan. But what happens if Etherscan is down, but the network is not down? So imagine that users might not be technical enough to understand that the chain is actually up. but the Explorer is down. And then you may assume that Ethereum is down. But it's not. It's just probably Etherscan going through some maintenance. So having multiple competing Explorers not only forces us to innovate and also to push ourselves harder, it also is good for the users because if one is under maintenance, the users can switch over to another Explorer. Even better is that we can coordinate our maintenance schedule. So that way, the liveness of the Explorer is guaranteed. So as to which one to choose, one over another, to be honest, I don't really have an advice. Also, it's not very fair. It's very personal. Because in Etherscan, you are being forced to use one design. So in Starknet, we are being spoiled by multiple Explorers. So if this design could be something that is more useful for you, it could be for you. And again, Explorers for everyone, so there's no way to cater for everyone. So having multiple Explorers sort of helps in covering like the gaps. Right? So for example, 80% like this design, but 20% do not like design, they can go for another Explorer. So I think we kind of complement each other in that front. Not only in the liveness of Explorer on the network, but also in how we display data. And I think that having multiple Explorers sort of like covers the entire area so that everyone is satisfied. Hope that answers the question.
And one more.
Yeah.
Does Voyager have a unique features that other Explorers don't have?
Unique features. Basically, the unique features are, this is a good one, are very, subjective and also dynamic. I say that because block Web3 is a trend. So back in the days where ERC721 wasn't there, there's no need to build features for ERC721. But now ERC7 is there is need to build that feature. So one thing that Voyager strives is that we observe what the community wants. So feedback is very important, and we'll try our best to build something that helps you to visualize the block data. Unique features, at the end of the day, they are the data that the user wants. So if you want something, feel free to request. My DMs are open, and you know how to reach me. Thank you so much for the question. Any more?
Thank you.
Thank you. Any more questions? Oh, we have one more over there.
I'm gonna ask something a bit technical. So, can you give me like an example of data that are very hard to aggregate or get without like the help of an explorer or an indexer to mediate? So, most data you can get directly from the node. Like, what are examples of data that are extremely hard to aggregate just by querying the node via RPC or something?
I think that's a very good question because it's something that people don't think a lot about. People take it for granted. One thing is that I want to view my past 5 transactions, right? So to view my past 5 transactions, we do not know which block the transaction has happened. So to do that manually, you need to like loop through the block from the latest, like block 100 is latest, you look at 99, 98, 97, 96, and to go through each of the transactions to see if the from address belongs to me. So for each call to the block, you need to make a call to the transaction to get the receipt, and you need to read if that transaction from address is from you. So doing that manually is probably going to be super tedious. And in the Explorer, it's just one page. Oh, this is my five transactions. They're being like shown. And yeah, hopefully that answers this question. That's one example, one easy example that I can think of right off the spot. Yeah, thank you. Thank you for the question. I guess we're done. Very cool. Thank you so much for your time. Thank you much for your attention. And thank you much to the Dollar Labs team for organizing this fantastic event. Pleasure to be here. Thank you.